Hey everyone, welcome to 197 Concepts. In this video, I will be telling you how the software MASM is going to change the number values because generally in mathematical form, humans will be seeing the numbers in a different manner, whereas all the electronic devices will be seeing the numbers or calculating the values in a different manner. So there's a bridge between these two numbering systems, or you can say the two numbering formats. Okay. So the very first thing that humans are using numbers is in the form of decimal system. Okay. Decimal numbering system. Whereas system, whereas all the electronic devices, digital electronic devices, not analog electronic devices, all the digital electronic devices that includes laptops, mobiles, computers, basically everything that is having a processor. Okay, so these devices will see the numbers in hexadecimal format numbering system. So what is the difference between these two? See, basically the decimal numbering system will count the values from 0 to 9. If you consider 0 as a whole as a number, then the decimal numbering system will have a count from 0 to 9, and if you remove this, it's 1 to 10. So a total of 10, a total of 10 numbers. That's why the name decimal numbering system. Whereas in hexadecimal numbering system, there are uh, of course there is 0 to 9 count. Okay, so 0 to 9 count. Along with this, after the completion of the count 9, it is going to start the count with the alphabets A to capital F. So if you count this total thing, it is 16 numbers. Okay, so now hexadecimal. Decimal itself tells we are having 10 digits. So these 10 digits are carried from 0 to 9, or it is counted from 0 to 9, and the remaining 6, hexa means 6. The remaining 6 values are counted using the alphabets capital A or small a to capital F or small f. Both are equally represented. So this is the main difference, and you might be getting confused about the binary numbering system. Okay, so this is the easiest one. This is nothing but it consists of logic 0 and logic 1. That's it, or you can call it as 8421 code also. Okay, so you can call it as the 8421 code. So decimal numbering system is the numbering system that we humans regularly use in the mathematical formats, whereas the hexadecimal numbering system is the system that is used by the processors to understand what the value we are giving, what the value is given by the user as the input. Okay, then the binary numbering system is the conversion of the hexadecimal number into the binary language, that is into the form of zeros and ones. So the processor will be able to understand only this binary numbering system. Then what is the use of hexadecimal numbering system? So binary numbering system is understandable by the processor only in the low level language. This is the least form, this is the lowest form of language system in a computer or in any digital electronic device. Whereas the hexadecimal numbering system, you can call it as the high level language representation of the low level language. For example, if you want to represent any number, let us take 16 bits. So I'm randomly taking 001 space 1110 space 1010 space 0101. Okay, so I'm having a total of 16 bits in the binary form. This will be represented in terms of hexadecimal, like by, okay, let us get a clarity here. So in a total, I'm having 16 bits, okay, 16 bits of binary information. In order to represent the hexadecimal number which is equivalent to this value will be given as for representing that specific value. You have to split these 16 bits into four segments as I have done before with the space. So let us do that. 0001 space. Then next, what I will just copy this and count it. Okay, so I've pasted it. So actually, I have to do it from the leftmost side. So starting from the least significant bit, 1, 2, 3, 4, then 1, 2, 3, 4, then 1, 2, 3, 4, then that's it, 1, 2, 3, 4. If you are having only these many of bits, say for example, I'm having 12 bits or I'm having 14 bits, then the excess bits should be replaced with a 0. Okay, so I have taken by default, I have taken zeros here, but if you get only 15 values, or for example, here 16 minus 3, you are going to get 13 bits. That means counting from 0, you are going to get only 12 bits. That means let's just count it from here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So these three zeros were not there. If you get only 12 bits, then you have to add three zeros in order to make it a 16-bit data. Okay, so this is about 16-bit. If you're talking about 8-bit or 4-bit or 2-bit, the values will change there. So maximum what I'm assuming is here is it is the information that a processor can access in terms of 8086 is 16-bit. So that is why I've taken a 16-bit number. Okay, so in this way I have to split four digits from the least significant bit, and each set of 4 bits will represent the 8421 code. This one is 8421, this one is 8421, this one is 8421, and this one is 8421. Now if you go with that, 8421, right? So 8421. So this, since only the last bit is activated, all the other bits are 0. This represents 1. So 1 space. In the same way here, 8421. So 8 plus 4 plus 2, that is 12 plus 2. That is 12 plus 2 will give us 14. Now if you see the hexadecimal numbers, 14 will be represented with the value E, since 15 is the last one, uh, and it is represented by F. Then what I'm having here, 10108 plus 2, that is 10. 10 is represented by the value A, and finally 0101 is 4 plus 1, that is 5. 5 will be represented similarly with the value 5. This is the hexadecimal representation. This is the hexadecimal representation of this 16 bits. Okay, so this is hexadecimal representation. Now, what is this actual value in mathematical form means we have to calculate the weight of these 16 bits. So what is weight? Starting from 2 power 0 to all the way up to 2 power 15. 16 means 2 power 0 up to 2 power 16. So how is that going to be calculated? I am coming from the most significant bit. Okay, so I am going to write that in the next line. So 2 cap 15 plus not plus multiplied by 0, because because the weightage of this most significant bit is 2 power 15, but its logic is 0. We should not add this one. We should not add this particular bit, hence it should be multiplied. So basic conversion is, if you are having any position, any particular bit, if you want to know if you are having the weightage of any particular bit, that should be multiplied with the state of that particular position. For example, I'm going to take this particular bit, this third position bit. Okay, not third, that is the second position, 0 1 2, this particular position, then it is logic 1, so this will be 2 power 2 multiplied by 1. Okay, in that way you can eliminate all these zeros and just you need to add all the ones. So if you're going to eliminate, let us go with this 2 cap 14 multiplied by 0 plus, okay, I will copy this and I will be, this is for 13, I need the plus symbol also. Okay. 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So that's the final value. So 14 is logic 0. It's going to be there. 13. And now I will go and change one by one. This is 12. This is 11. This is 10. This is 9. This is 8. This is 7. This is 6. This is 5. This is 4. This is 3. This is 2. Not 12. This is 1. And this is 0. Okay. Now coming from the most significant bit, I have this as 1. Then 1, 0, 1, 0. Okay. 0, 1, 0, 1. Then 0, triple 1, 0, triple 1, and then 1, triple 0. So this is the conversion of this value. Okay, I'm writing the weights. So now since 15th position is 0, 14th position is 0, 13th position is 0, and the 10th position followed by 8th position, 6th position, 4th position, 3rd position, 2nd position, not the second one, 1st position, all these are zeros. I can eliminate all those. I can eliminate all those values. Okay, since the final value from those side, that side will be 0. So I'm just going to keep all the ones. Other values, I'm just going to erase those, because if you multiply any value with 0, you will get a resultant as 0. So that particular term is considered 0. So there is no need to add that particular term. Okay. So this value is going to be eliminated and this value is going to be eliminated. This is the final value that I have to add. So this one will be equal to, so 2 power 12 into 1. Let's go from the bottommost side. 2 power 0 is 1 into 1. That will give you 1 plus. Then 2 power 2 is 4. 4 into 1. That's again 4. Okay. Then 2 power 5 is 32. 2 power 5 is 32. 4096. 2 power 12 is 4096. 2 power 11 is 2048. 2 power 10 is 1024. 2 power 9 is 1 509, 512. 2 power 7 is 128. 2 power 5 is 32. 2 power 2 is 4, and 2 power 1, 2 power 0 is 1. So I have to add all this. Let me add it quickly. So 4096 plus 4096 plus 2048 plus 1024 plus 512 plus 128 plus 32 plus 4 plus 1 equals 7845. So this is the decimal value which is equal to 1EA5. So 7845 is the decimal value. So if you go in the reverse manner, if you want to represent the value 7845 in the MASM, that is in hexadecimal numbering system, you are going to write that as 1EA5. In other words, we can say that when you give the value 7845 of a real mathematics value, that is the decimal numbering system, to the digital electronic device, it's going to convert the 7845 into 1EA5. Okay, 1EA5, and this 1EA5 is again going to be converted into 16-bit information. So if you want to check it, let's check it once. I have already a hexadecimal converter here that is open. So decimal value, what is the decimal value? 7845. Let's go in the reverse manner. 7845. If you convert this, what we get is 1EA5. Okay. So this means whenever you give the value 7845 to a digital electronic device, first of all, it's going to be converted into hexadecimal value as 1EA5. And this hexadecimal value is going to be converted into the binary form. So that's a huge difference between the decimal, hexadecimal, and binary numbering system. And these three numbering system is very crucial in order to understand the MASM and the operations that we are going to do in MASM. Okay, so that's it for this video. Let's meet in another video.